All right, let's dive into some AI. Today, we're going deep on a paper all about how machines understand images.
Oh, yeah.
It's called Pix2Cap-COCO, Advancing Visual Comprehension via Pixel-Level Captioning.
Catchy title.
Right, and it's all about teaching AI to describe images in incredible detail.
Way beyond just like
What?
like just labeling a dog.
Yeah. Imagine a computer that can not only identify a dog in a park, but tell you it's like a fluffy golden retriever chasing a bright red frisbee.
Wow.
That's the level of detail we're talking about here.
So it's like almost like a human is describing the image.
Exactly.
It's pretty cool.
And the key is this new data set called Pix2Cap-COCO.
Okay.
Now, it's built on the existing COCO data set, which a lot of our listeners are probably already familiar with.
Yeah, for sure.
But it takes things a step further with these incredibly detailed captions for each object in an image.
I mean, really detailed. We're talking like 23 words per caption on average.
Oh.
Using GPT-4V, no less.
So they're using AI to generate the captions.
Yeah, in the annotation process.
Smart. So we're not talking about just a handful of images here.
No. This is big. We're talking over 20,000 images.
Wow.
And a huge amount of captions, something like 167,000.
Okay, so how do they actually make this data set?
Yeah, that's a great question. I'm guessing it wasn't just a bunch of interns sitting around labeling images all day.
Probably not.
Definitely not. They had to use this really cool automated pipeline.
Okay, I'm intrigued. Tell me more.
So they started with the images from COCO.
Which already had object masks.
Exactly. And then they use this technique called set of mark, or SUM.
Okay, and what does that do?
It's basically like putting a unique ID tag on each object.
So each object gets its own little identifier.
Yeah, you actually see this when you look at the images. There's this bright numeric ID right in the center of each object.
Cool. And then they use GPT-4V to actually generate the description for each of these tagged objects.
That's right.
So instead of relying solely on humans to write these descriptions, they leveraged AI to speed up the process.
And create a much larger data set.
Very clever.
It's a really cool approach.
So why go through all this effort? What's the point?
Well, they're introducing this new task called panoptic segmentation captioning.
Oh, wow. That's a mouthful.
Yeah, no, it's a bit of a tongue twister, but think of it this way. The AI has to not only outline every single object in the image precisely,
Okay.
but also describe each of those objects with rich detail, all at the same time.
So it's doing two things at once.
Yeah, it's like taking object detection and image captioning and, mashing them together.
So instead of just drawing a box around a cat and saying cat, the AI has to like perfectly outline the cat
Yeah.
and then be like, a sleek black cat with piercing green eyes is lounging on a red velvet cushion.
Exactly. It's like teaching a machine to be an art critic.
And a poet.
Yes. It really highlights how Pix2Cap-COCO is pushing the boundaries of what AI can do.
So this brings us to the why should you care part.
Yes, the big question.
What does this all mean for someone who isn't, an AI researcher?
Well, imagine a world where AI can understand images with the same depth and nuance as a human.
Okay, I like where you're going with this.
This could revolutionize so many things, like image search or accessibility tools for the visually impaired.
That's a great point.
We could have AI systems that generate detailed descriptions of medical images for doctors, or even help archaeologists analyze artifacts.
So it's not just about cool tech demos.
No. This is real-world impact.
We're talking about AI that could potentially change our lives.
Exactly.
That's pretty exciting. So how do they actually train an AI to do this? Do they just throw this data set at any AI model?
Well, not exactly. They propose this baseline model called Pix2Cap, which builds upon an existing object segmentation framework called XDecoder.
Okay, so they're not starting from scratch.
No, they're taking an existing tool and adapting it for this new challenge.
I like it, building on what we already have.
Makes sense, right?
Yeah. So how do they measure how well these models perform?
Well, they use a combination of metrics.
All right, break it down for me.
So for segmentation, they rely on the standard mean average precision, or MAP for short.
Okay. And what about for the captioning part?
They use a bunch of metrics that are commonly used to evaluate how well, generated text matches human written text.
So they're comparing the AI's writing to what a human would write.
Exactly. Metrics like BLEU, cider, rouge, and spice.
Oh, wow. That's a lot of acronyms.
Yeah. But they basically all try to measure how well the AI is capturing the meaning and the nuances of the image in its description.
I see. It's not just about using the right words.
It's about telling the whole story
Right. The AI has to really understand what's going on in the image.
and convey that understanding in a way that makes sense to us humans.
Now, the big question, does Pix2Cap-COCO actually make existing large multimodal models better?
Mm-hmm.
I mean, that's the ultimate test, right?
Yeah, for sure. And they actually show this by fine-tuning GPT-4
GPT-4 what now?
GPT-4
Okay, another large multimodal model.
Right, using Pix2Cap-COCO, and the results are really impressive.
Okay, I'm all ears.
They saw this huge improvement, like 5.1% overall improvement on the VIP bench.
That's a pretty big jump.
Yeah, and the VIP bench is like the gold standard for evaluating these multimodal models, so it's a big deal.
What kind of improvements did they see?
Well, the biggest one was in recognition accuracy. It went up by like 11.2%.
Wow, that's significant.
And even more impressive, a 22.2% improvement in the quality of the language generation.
So it's not just understanding the image better, it's also describing it in a more sophisticated way.
Exactly. The captions are more detailed, more accurate, and more human-like.
So Pix2Cap-COCO is not just some theoretical exercise. It's a tool that actually makes AI better at understanding our visual world.
That's the beauty of it. And they also saw improvements on the visual genome data set, too.
Ah, so it generalizes well.
Yeah,
Yeah.
especially in those captioning metrics we talked about earlier, like
Yeah.
cider, rouge, and spice.
It's like they're giving these AI models a whole new level of understanding,
Yeah.
a deeper appreciation for the nuances of images.
Yeah, and the implications of that are pretty mind-blowing.
But before we get too carried away, it's time for our Novel Notions segment.
All right, let's get speculative.
Time to put on our thinking caps and brainstorm some potential research directions inspired by this paper.
I love this part.
Me too. All right, buckle up, everyone. We're about to venture into some uncharted territory.
Let's do it.
Okay, so we've talked about how Pix2Cap-COCO could, revolutionize image search and help us understand complex scenes better.
Right.
But I think there's an even wilder idea out there.
Oh.
What if we could use this data set to teach AI not just what an image shows, but what it feels like?
You're talking about emotions.
Exactly. Imagine an AI that could look at a photo and say, this image evokes a sense of joy and togetherness.
Okay, yeah.
Or this painting has a melancholy, almost haunting quality.
So we'd be going way beyond just recognizing objects and describing their attributes.
Right. We'd be teaching AI to understand the emotional language of images.
The subtle cues that convey mood and atmosphere.
It's like teaching a machine to be an art critic.
Or even a therapist.
Right. We could have AI systems that analyze photographs to understand a person's emotional state.
Or understand the emotional impact of a piece of art.
It would be a huge leap forward for AI to connect with us on a deeper level.
To really understand the human experience.
But to get there, we'd need data sets that go beyond physical descriptions,
Right, we'd need images labeled with emotional tags.
answering the full spectrum of human feelings.
It would be a massive undertaking.
For sure. But imagine the payoff.
An AI that can help us better understand our own emotions.
And the emotions of others.
Just by analyzing images.
Wow, that's a powerful thought.
It really is.
This idea of an AI that can read emotions from images is mind-blowing,
It could change how we interact with art, with each other.
even with ourselves.
And it all stems from the foundation laid by datasets like Pix2Cap-COCO.
Yeah, by pushing the boundaries of visual comprehension, it's opening up entirely new avenues for AI research.
Exciting times.
All right, on that note, let's wrap up our deep dive into Pix2Cap-COCO. We've covered a lot, from the technical details of the data set and the model
Yeah, we went deep.
to the far-reaching implications for the future of AI.
Definitely a lot to think about.
Before we sign off, just a reminder, you can find the link to the Pix2Cap-COCO paper in the show notes.
And links to some of the other datasets and resources we talked about.
And of course, our usual disclaimer.
Yeah.
Our Novel Notions segment is all about brainstorming and speculation. We can't predict the future, but it's fun to imagine.
That's the beauty of research.
Exploring the unknown.
Pushing those boundaries.
Exactly. And who knows, maybe one of these wild ideas will spark the next big breakthrough in AI.
Fingers crossed.
So until next time, keep exploring, keep questioning, and keep pushing those boundaries.
Couldn't have said it better myself.
Thanks for joining us on this deep dive.
It's fascinating to think about how far computer vision has come.
It really is.
Like, we've gone from just teaching a computer to recognize a cat in an image to AI that can describe its breed, its color, even if it looks playful or sleepy.
It's true. It's like we've gone from blurry black and white photos to high definition, full color images.
Yeah.
But in the world of AI.
Exactly.
Speaking of that evolution, I think it would be helpful to give our listeners some context.
Yeah.
Like, what were some of the key milestones that led up to this point?
Yeah, good point. Well, it all boils down to data sets, right?
Right.
In the early days, we had ImageNet,
ImageNet, a classic.
a massive collection of labeled images.
Huge.
Revolutionary at the time.
Oh, yeah, for sure.
But the captions were pretty basic.
Like, what kind of basic are we talking?
Just simple labels like dog or car or tree.
Yeah.
Not very descriptive.
Yeah, that's like having a dictionary but no sentences.
Exactly. You have the words, but not the story.
Right.
And then along came COCO, which added more detail with object bounding boxes and segmentation masks.
So we're starting to move beyond just like recognizing an object
Right.
and into like spatial understanding.
Yeah, like teaching a machine not just what things are, but where they are.
Right, exactly.
And then we saw data sets like visual genome trying to capture even richer information,
Yeah,
trying to provide more detailed descriptions, relationships between objects.
getting closer to like real understanding.
Yeah, true visual comprehension, but it still lacked that precision and granularity that Pix2Cap-COCO brings.
Especially that pixel level alignment.
Yeah, exactly. That's key.
So each of these data sets, they kind of built upon the previous ones, right?
For sure.
Adding more detail, more complexity, pushing the boundaries further.
It's like a staircase
Yeah.
leading us up to this new era of visual understanding.
And Pix2Cap-COCO is like a big step up on that staircase.
Definitely. Setting a new standard for fine-grained visual understanding.
Okay, enough with the history lesson.
All right.
Let's get back to the Pix2Cap model itself.
Sure.
So you mentioned earlier that it's built on an existing architecture called X-decoder.
That's all right.
Can you break down how they adapted it for this new task?
Yeah. Yeah, so X-decoder is a really powerful framework for object segmentation.
Okay.
It follows this classic encoder-decoder structure.
Oh, the encoder-decoder, a tale as old as time.
Pretty much. So the encoder, it analyzes the image and extracts features at different scales.
So it's like breaking down a complex painting into its individual brushstrokes.
Yeah, like that. Creating a multi-layered map of the image, highlighting everything from the basic shapes to the intricate details.
And then the decoder takes those features
Yeah,
and uses them to generate segmentation masks.
right, which are essentially pixel-level outlines of each object in the image.
So the decoder is like piecing together a jigsaw puzzle
Yeah,
using the features provided by the encoder.
that's a great way to put it.
So the X-decoder is already good at, identifying and outlining objects.
Right.
What's the secret sauce they added to make it generate captions as well?
Okay, so the key addition is the captioning head.
Captioning head.
Yeah, it's this separate neural network module that's attached to the decoder. And it's a language specialist,
Ah, I see.
trained to take those object features from the decoder and translate them into, natural language descriptions.
Like having a bilingual expert who can fluently switch between the language of images and the language of words.
Exactly. And this captioning head relies on a transformer.
Oh, a transformer.
Those things that power ChatGPT and stuff.
The rock stars of the AI world.
Yeah, they're pretty good at understanding relationships between words.
And capturing those long-range dependencies.
That's crucial for generating, coherent and grammatically correct descriptions.
So in the Pix2Cap model, the transformer is like the storyteller,
Yeah.
taking those object features from the decoder and weaving them into this detailed narrative about each object.
Like a screenwriter adapting a visual scene into a compelling script.
Exactly. And the entire process, from encoding the image to generating the masks and captions, it's all trained together, right?
Yeah, end to end.
So the model learns to perform all these tasks simultaneously,
As a unified system.
like a well-oiled machine.
Exactly.
But how do they make sure this model is actually learning correctly?
Well, that's where the training process comes in.
Right. The data is key.
You got to feed it tons of examples.
Images paired with their corresponding pixel-level captions.
And through this process, the model learns to map the visual input to the desired output.
It's like practicing a musical instrument until you can play a piece flawlessly.
Yeah, or like showing an artist countless paintings and descriptions until they can create their own masterpieces.
But then how do you judge the quality of those masterpieces?
That's where the evaluation metrics come in.
Ah, the metrics?
Yeah, so for the segmentation part, they use mean average precision, or MAP, which basically checks how well the generated masks align with the actual objects.
So it's like comparing the AI's drawing to the original artwork.
Exactly. And for the captioning part, we have our trusty metrics like BLU, cider, rouge, and spice.
Ah, yes, the captioning crew.
They compare the AI-generated captions to human-written ones, assessing vocabulary, grammar,
making sure the meaning is there.
It's like having a panel of art critics judge the AI's descriptive abilities.
And the results are pretty impressive.
Yeah.
The Pix2Cap model, trained on Pix2Cap-COCO, achieves state-of-the-art performance on this panoptic segmentation captioning task. It's really opening up new possibilities.
Definitely.
Okay, I think we've covered a lot of ground here. It's time to shift gears and go back to our novel notions segment.
All right, let's get back to brainstorming.
We've already come up with some cool ideas,
Yeah, some good ones.
but I feel like there's more to explore.
I agree. This data set feels like a launchpad for all sorts of new research directions.
All right, let's see where our imagination takes us. Okay, so we've talked about Pix2Cap-COCO and how it could revolutionize image search or even help us understand like complex scenes better.
Right. Right.
But I think there's an even wilder idea out there.
Oh, really? I'm intrigued.
What if we could use this data set to teach AI not just what an image shows, but what it feels like?
You're talking about emotions?
Exactly. Like imagine an AI that can look at a photo and say, this image evokes a sense of joy and togetherness.
Okay. Yeah, I see what you mean.
Or this painting has a melancholy, almost haunting quality.
So we'd be going way beyond just like recognizing the objects and describing them.
Right. We're talking about teaching AI to understand the emotional language of images.
The subtle cues that convey mood and atmosphere.
It's like teaching a machine to be an art critic.
Or even a therapist.
Right. Like we could have AI systems that analyze photographs to like gain insights into a person's emotional state.
Or understand the emotional impact of a piece of art.
It would be a huge leap forward for AI to connect with us on that deeper level.
To really understand the human experience.
To get there, we'd need data sets that go beyond just, physical descriptions.
Right. We'd need images labeled with like emotional tags.
Capturing the full spectrum of human feelings.
It would be a massive undertaking.
For sure, but imagine the potential payoff.
An AI that can help us better understand our own emotions.
And the emotions of others, just by analyzing images.
Powerful stuff.
This idea of AI that can read emotions from images, it's mind-blowing.
It could change everything, how we interact with art, with each other.
Even with ourselves.
It all comes back to the foundation laid by data sets like Pix2Cap-COCO.
Yeah, by pushing the boundaries of visual comprehension.
Opening up all these new avenues for AI research.
Well, that's a great place to wrap up our deep dive into Pix2Cap-COCO.
Yeah, it's been a great discussion.
We've covered a lot of ground today. From the technical details of the data set and the model
We really went deep.
to the broader implications for the future of AI.
A lot to think about for sure.
Before we sign off, don't forget to check out the show notes for the link to the Pix2Cap-COCO paper.
And all the other resources we mentioned.
And of course, the usual disclaimer. Our Novel Notions segment is all about brainstorming and speculation. We're not fortune tellers.
Yeah, but it's fun to think about the possibilities.
That's what research is all about, right? Exploring the unknown, pushing those boundaries.
Absolutely. And who knows, maybe one of our wild ideas will inspire the next big AI breakthrough.
Here's hoping. So, until next time, keep exploring, keep questioning, and keep pushing those boundaries.
Thanks for listening, everyone.
Thanks for joining us.